For our project, we did a landline. My name is Mitchell.
I'm Jordan.
So the landline is just like a normal phone you have like in your house, and off to the side here are all like the parts. Like this is like the casing, the keypad, the circuit board, the screen, all that stuff.
Landlines aren't really used anymore in homes. They've kind of switched to mainly just cell phones. When I was a kid, I know I had a landline in my house. I'm sure everyone else did too, but we don't have it anymore. It's pretty much just translated over to cell phone. So we had it. I had an extra one just because we don't use it anymore. So yeah. This is my selected part. It was the silicone keypad mold, which was basically right behind Mitchell's part. It's just a silicone keypad mold. It's inside the phone, and it is the piece in between the numbers and the circuit board. So when you press the numbers, it's kind of like a soft, it's like a soft, just like button, and it connects with the circuit board, which carries out its desired function through the circuit. And this is the piece right here. And then I was talking about Mitchell's piece, which is this one right behind it, and then it connects to the circuit board. On one side of the circuit board, you can see that there's little like circles, which is where it connects to the this right here. And like I said, it carries out the desired function whenever you press one of the buttons, and it connects to the circuit board.
For my part, I did the keypad. It was just a piece, it was a piece of plastic that works hand in hand with the silicone keypad. Pressing like one of the numbers like triggers the pressure plate, and not like it pushes down on Jordan's piece, which then goes into the circuit board. And yeah, that's basically it. There's numbers on them, so you know which button you're pressing. Descriptions and functions. The function of the landline is to allow you to communicate with other people over a far distance. The outside plastic material is what you hold in your hand. It's like the casing when you're using the phone. It also protects the motherboard and other components of the phone. Holes on the back of the phone allow like air to flow through it, like back here, and then so like this allows the phone to stay cool so it doesn't overheat. The battery also goes in the back of the phone, and that connects to the motherboard. This is what powers the phone and allows it to operate. There's a casing that holds the battery in place so it's not hanging out of the phone while you're using it. It has the case that holds it in has a foam piece on it, so it's not like rubbing on the battery and like wearing it down. The screen is at the top front part of the phone, and this is like what displays the numbers that the number of the person you're trying to call, and it shows you like if you're receiving a call, stuff like that. There's a part that goes on top of the screen that protects it, so like you don't get fingerprints on there, so it doesn't get wet. And then the motherboard's in the middle, which kind of ties it all together. To use the phone, you need to first get it installed by a company. This is what the landline allows you to call other landlines. It will send a call. Like when you type in their number and press the call button, it'll send a call to the person who you're trying to contact, and if they answer, you'll be able to talk with them through the phone. You would use this phone anywhere inside your house. You could be sitting, standing, or laying down when you're using the phone. You can make a call from anywhere inside your house. It can be raining, snowing, or hailing outside. The phone can still work.
All right.
The phone is made in mainland China, Malaysia, or Mexico. The landline is built in one of the manufacturing facilities and then shipped to the U.S. for sale. They're sold online or in stores like Target. Once the landline is bought, it is installed in the home and used by the buyer. The phone is good for 2 to 3 years before the battery starts to run down. Then the company that made this one, VTech, encourages you to recycle the phone. Parts are then salvaged if they can be or thrown away. The cost for just one landline is about $25, but you can get up to 8 or 10 of them for like $300. Testing.
All right. So This is the testing we did. One of the criteria was testing it. There was like it has on here, the continuity test, ferrous metal test, hardness, and then all the measurements like mass, volume, density, and surface area. We did like physical measurements of the phone, and then we did on-shape measurements. So this is my part, this is Mitchell's part. This is just kind of, I did this in Google Sheets. Neither of them, neither of them conduct electricity at all. I mean, my part's silicone, Mitchell's part's plastic, no metal inside of either of them. So, I mean, it wasn't really a shock when it didn't conduct anything. Failed the ferrous metal test. The hardness, it's super like easily scratched. It's not any like super crazy material. It's just silicone and plastic. And then the mass, they actually weigh the exact same. They're not gonna weigh a bunch of weight when we measure them. It's gotta be handheld. So they didn't weigh a bunch. For volume, we measured it by doing the water displacement test. And for density, we did just mass divided by the volume. Surface area, for my part and Mitchell's part, it was almost impossible to measure the surface area, so we just did it inside of on-shape after we made it. And then the hand flexor test, my part, silicone, so I mean, you can bend it, move it, do whatever, and it's gonna go back to normal, so it's super strong. And then Mitchell's, you can barely bend it, it breaks. As you can see, there's pieces everywhere because they all fall apart. So what we got for the measurements on these ones, you can see for mine, the on-shape and the real life measurements are somewhat similar. Surface area, obviously we couldn't really measure in real life, so we just kind of did the on-shape measurement. But for density, I mean, it was pretty close, less than 3/10 off. Volume was close. Mass was close. Obviously, we didn't expect it to be hand-in-hand perfect, but I would say that for me and Mitchell that we were pretty happy with what we got, considering like it's not gonna be perfect, but it's really pretty close. So.
Here's some of the sketches and measurements of our pieces. Mine was 3.7 centimeters wide and 5.8 tall. Jordan's was about 3.7 centimeters wide, but 10 centimeters tall.
Yeah, so we did drawings for all of them, every single part, not just the parts that we did, but I really went in depth on the parts that we went and studied more, just due to the fact that we're gonna need to know every single little part and piece and measurement for on-shape. So it's really a lot easier to just draw it out, and then when we went into on-shape to build it, just to have something to reference off of to make it a lot easier. So.
Here are our on-shape models. Mine wasn't too hard to build. It's on the left, and Jordan's is on the right. The plastic keypad is made from cellulose, coal, natural gas, salt, and crude oil through a polymerization and condensation process. Polymer formation process links small molecules together, accompanied by the elimination of byproducts. The plastic is then put into the phone for its final use.
And the silicone keypad mold, I know Abby kind of said it in her presentation how silicone's made, but I'll say it again, it's made from carbon, hydrogen, oxygen, and silicon. Silicon comes from silica, which is derived from sand, and then the keypad is just formed into compression molding. Injection molding, you can do multiple different types of molds. For this one though, we're pretty sure it's compression molding, just due to the fact that they have to make so many of these phones that they just kind of put it in and compress it, then send it through the assembly line. And the process uses heat to pressure to form the keypad, and then like I said, the keypad is then put into the phone for its final use.
The plastic has a very long life, therefore it can Recycling early in the right way is extremely important. Plastic has two ways of being recycled, either being melted or broken down into flakes. When being melted, it gets turned into pellets, which then get used to manufacture new products. Or when it's being broken down into flakes, it can be used for compression molding, 3D printing, powder coating, and more.
So silicone can be recycled pretty well, but it does require a special silicone recycling plant. It's broken down into tiny pieces where it's then heated up to extremely high temperatures. The resulting vapors are then cooled and collected as liquid. This liquid is in the form of silicone, but it's been degraded, so it's not as good as the original silicone that it was originally made from, but it's still there and it can be used for things like flooring and mats.
That's it.
That's it.
Okay.